Dear students, question number 41 says that the steady state current through the resistor of resistance 4 ohms when both switches are closed as compared to the current when both switches are open is. Now dear students, when both switches are open, then the effective circuit is broken and there is no pathway for the current to flow. Therefore, the current through the circuit, or specifically through the 4 ohm resistance when the switches are open, is equal to 0. Now dear students, let us try to find out the current through the 4 ohm resistance when all the switches are closed. Now when this switch is closed and also this switch is closed. Dear students, we know that in steady state there is no net current through the capacitive arm. So no current will flow through this arm and the effective resistance of the circuit will be due to 4 ohms and 2 ohms in series. So the net resistance would be equal to 2 plus 4, that is equal to 6 ohms. Whereas effective EMF in this circuit would be equal to 20 volts battery and this 8 volt battery combined would lead to an EMF of 20 minus 8 because they are in opposite polarity to each other. So that would be equal to 12 volts. The current therefore after closing the switches will be 12 divided by 6, that will be equal to 2 amperes. Now dear students, we can see that when both the switches are closed, the steady state current is 2 amperes more than the current when both the switches are open. Therefore, the correct answer for this particular question should be option number 2. Now dear students, let us proceed to the next question, and the next question is question number 42. Dear students, question number 42 says that electrostatic field in a region is given by E is equal to Yxi cap plus Zx j cap plus Xy k cap volt per meter, where X, Y and Z are in meter. If electric potential at origin is 0, then potential at 1 meter, 1 meter, 1 meter is. Now dear students, we know that the potential difference between any 2 points can be written as negative of the integration of electric field dot dr. Herein it is given that the potential at origin is 0, so final potential minus 0 should be equal to negative of the integration of limits 0, 0, 0 till limits 1, 1, 1. Substituting the values of electric field, we can write Yz I cap plus Zx j cap plus Xy k cap. Now dear students, substituting the values of dr vector, which can be written as dx I cap plus dy j cap plus dz k cap. Taking the dot product, we can further write it that negative of the integration 0, 0, 0 till 1, 1, 1 y z dx plus z x dy plus x y dz. Now dear students, this particular expression can be written as differential of x, y, z. The integration is from origin, that is 0, 0, 0 till 1, 1, 1. The integration of dxyz is equal to x, y, z. Substituting the values 0, 0, 0 till 1, 1, 1, we get the answer as minus 1 volts. So dear students, the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 43. Dear students, question number 43 says that a uniform wire is bent in form of a circle as shown in the figure. The effective resistance between A and B is maximum if theta is equal to. Now dear students, at this particular angle theta, the length AB can be written as r into theta, because the length or the arc length in a circle is equal to radius multiplied by the angle. Similarly, the length as marked in the figure would be equal to r multiplied by 2 pi minus theta. Now dear students, if the resistivity of the wire is rho, we can write that the net resistance across AB is due to the parallel combination of this part and this part. The resistance of first part can be written as R1, which will be equal to the resistivity rho multiplied by the length, which will be r theta, divided by the area of cross section. The resistance of the second part, that is this part, can be written as resistivity multiplied by the length, which will be r into 2 pi minus theta divided by area. Since these two resistances are in parallel, the net resistance can be written as R1 into R2 divided by R1 plus R2. Now, substituting the relevant values of R1 and R2 in this equation, we can get rho by A into R, theta into 2 pi minus theta divided by 2 pi. Now dear students, for small r to be maximum, the differentiation of small r with respect to theta should be 0. Now differentiating this expression, we get the differentiation to be equal to rho r by 2 pi a into 2 pi minus 2 theta. Let us put it equal to 0. Solving this, we get that theta is equal to pi. Therefore, the theta, when it is equal to pi, the resistance between A and B will be maximum. Theta is equal to pi also corresponds to 180 degrees. So the correct answer for this particular question should be option number 1. Now let us proceed to the next question, which is question number 44. Now dear students, question number 44 says that the current through the battery just after switch S is closed is. Now, a circuit with capacitors and resistors is given. Dear students, we know that just after closing the switches, the capacitors behaves like short circuits. That is, they allow the current to pass through them without any hindrance. So, just after the switch S is closed, we can replace these capacitors with conductive wires. We can easily see that 6 ohm and 3 ohm resistances are in parallel, and the net resistance of these two resistances would be equal to 6 into 3 divided by 6 plus 3, that is equal to 2 ohms. Now dear students, this 2 ohm resistance and this 6 ohm resistance are in series. So the net resistance, that is R net, would be equal to 2 plus 6, which is equal to 8 ohms. Now the effective battery EMF in the circuit is equal to 16 volts. So the current will be equal to 16 divided by R net, which is 8, that will be equal to 2 ampere. So dear students, the correct answer for this particular question should be option number 3. Now let us proceed to the last question of this test, that is question number 45. Dear students, question number 45 says that in the circuit shown in the figure, no current flows through the 8 ohm resistor. Then the potential difference between points A and B, that is VA minus VB, is. Now dear students, it is given to us that no current flows through the 8 ohm resistor. That would mean that there will be no potential drop across the 8 ohm resistor. Let us mark this point as point F. and apply KVL across path A to F to B. It can be written as potential of A, as we are moving from this point to this point along the shown direction. The potential at A, which is unknown, plus 20 volts, which will be the potential difference as experienced as we move across the battery. As we move from F to B, a potential gain of 6 volt will also be experienced. Now, since the potential drop across the 8 ohm resistor is 0, this should be equal to potential at B. Now dear students, we can calculate that VA minus VB will be equal to minus 20 minus 6 or minus 26 volts. So the correct answer for this particular question should be option number 3. So dear students, this concludes our discussion of the physics portion of the first test of the All India Caste Test Series Medical 2019. I wish you all the best for your future endeavors and in the future exams. Thank you.